This is the section 1.8, Interpreting Graphs. We have different kinds of values that we can see from a graph. We're going to start with the x and y intercepts. With x and y intercepts is where it crosses the x or the y axis. The x intercepts on this example would be right here and right over here. How we make the indication of what they are is when they have a negative 3x value, and your y value is always going to be 0. The other x-intercept is over here, which is 1, 0. And we write it as an ordered pair. For the y-intercept is where it crosses the y-axis, right here. And we're going to write this one as 0, negative 1. And the x value will always be 0 on the y-intercept. So the way I like to remember is that if I'm looking for an x-intercept, I have an x value. If I'm looking for a y-intercept, I have a y value. The line of symmetry is the line where the graph looks the same on both sides. And so I'm going to make a dashed line to indicate where it is. And so if you were to fold this paper over, it looks the same on this one as it does on here. We kind of ignore the x and y axis. It's just the graph that we're looking at. The answer to this one is x is equal to negative 1. So anytime you have a vertical line, it's going to be x equals. And I'm going to write vertical line. If I were to flip this around and it looks like it's on the y-axis, then it's going to be y equals. And this one would be y is equal to negative 1. So I'm going to put y equals horizontal lines. Next, when we're looking at positive and negative graphs, what we have to look at is the whole thing. I'm going to give you the answer for a parabola. If it's looking up like this, the answer is positive. That means that if it's looking down, it's negative. On a line, if you read it from left to right and it looks like it's going up, it's positive. And if it looks like it's going down, it's negative. On complicated equations like this one, what you try to do is pretend you have a string and pull it. And when you pull it, it looks like it's going down, it would be negative. So this example is negative. We won't have these type of complicated answers in our test. Ours will be about parabolas and lines. Increasing and decreasing. For our examples, they're always going to have two general ideas. So I'm going to do a parabola that's facing up. And from here to here, it's decreasing because it looks like it's going down. And then from here to here, it looks like it's increasing. I'm just going to put D and I. For a parabola that looks like it's looking down, if you read it from here to here, it looks like it's increasing, even though the arrow looks down, because how you read them is from left to right. So this is increasing. And from here to here, it's decreasing. On a line, if it's positive or going up, it's increasing. And if it looks like it's going down, it's decreasing. So what happens in a complicated one like here is that you have several sections. And that from here to here, if you read it from left to right, it looks like it's decreasing. And then we can look at it from here to here. From here to here, it looks like it's going up, making it increasing. And then the rest of the graph looks like it's decreasing. Relative maximum or minimums are points. So what we're looking at is this point right here. And that looks like it's low, so this is called a relative minimum. It's not really the actual minimum because this graph can keep going on forever, and that's why we call it a relative minimum. And then over here we have a maximum. It looks like the highest point on the graph, but not really. Like I mentioned, it does keep going on forever, so that's why we call it relative. On a line, there really isn't any maximum or minimums because they'll keep going on forever. So there's no max nor min. On a parabola, the U-shaped ones, this one would be its minimum because the rest will keep going up higher. And then this one is its maximum. How we indicate it is by the order pair of that point.